Testing, testing. All right, I think we are live according to YouTube Studio. So without further ado, let's go ahead and get started. So today is another day of your daily dose of LeetCode. Probably some of you have noticed, if you've been keeping up with the channel for a while, you've noticed that I've made some updates to the channel. I'm constantly trying to figure out new ways to expand my reach, to get more people out here, just to get more people involved in the community. Again, I know I've been in that position before where it's difficult to study LeetCode, difficult to stay consistent with the study habit. So really hoping that this stream helps a lot of those people that are looking to sort of transition to doing LeetCode. Hopefully this provides like a one-stop shop for you just to watch some videos and sort of keep up with the whole practicing bit of it. So we left off yesterday sitting at 122 questions, which is pretty nice. I'm really happy with the progress we're making. For anyone that's new here joining, we have a total of almost 600 questions, and like I said, we're starting from question 0 going all the way through, and that's exactly what we've been doing. I sort them from acceptance, from highest to lowest for each of the different categories. So let's see where we left off yesterday, and we'll just go ahead and continue from there. So we have sort integers by the number of 1 bits. So let's see what we have here. You're given an integer array R and sort the integers in the array in ascending order by the number of ones in their binary representation. In the case of 2 or more integers have the same number of ones, you have to sort them in ascending order. Return the array after sorting it. So I think, and it's funny that I'm looking at this one because there's like this new explore card that LeetCode has, and I'm pretty sure it's free. I think I was looking at it earlier. Yeah, detailed explanation of sorting. I was looking over this one and looking at non-comparison counting sort, or I'm sorry, bucket sort. I think that could be like a good method to use here. And we can sort of, I want to draw this out to see if that's going to be the way. Excalidraw. Maybe we can also just sort of get the, let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8. 0 is the only integer with 0 bits. 1, 2, 4, 8 all have 1 bit. Okay. So integers array and sorting order. Okay, so for 0, we can just start writing everything, right? We have 0, we have 1, we have 2, we have 3, we have 4, 5, 6, and then 7. Oh, and then we also want the 8, right? So let's just do 0, 0, 0, and then we'll put our 8 right over here. So here, I think what we can do is we can, like for each one of these that we count, that will be the, like imagine we have a bucket. Let's say our bucket is something like this, where if it's just 0, then we put 0 in there, and then for 1, right, we can say it's going to be 1, 2, and then we get to 3, which has 2, so that will be 3. And then 4 has 1, so that will be that. 5 has 2, 6 has 2, 7 has 3, and then 8 has 1. So I'm sort of thinking that our buckets can be each of the, let me see, and is this how we want to, 0, 1, 2, 4, 8, 3, 5, 6, and 7. Yeah, so I think we can use a bucket sort here. And these should all be sorted in ascending order just by the nature of, let me see, all integers have 1 bit in the binary representation. You should just sort them in ascending order. Oh, I see, but then the actual array needs to be sorted too. So we could sort it, we could have the sorting be the first thing we do. So let's think about our plan here. We can say sort the input array using quicksort, and then go through each number, calculate number of ones, place in bucket, and then loop through values, concatenate result. Right, so I think this is a good way of us to approach this. Seems like a nice question. The like to dislike ratio is really good. So let's go ahead and figure out let's go ahead and figure out what we're going to do here. All right, so let's do the first thing where we will sort this input array. So we'll just use the spread operator here because I want to clone this. We'll do A, B, A minus B because I want to start off with increasing order. Now what I want to do is I want to create a function that will count the number of ones in the given number, right? So count set bits. I think there might be an even easier way of doing this, but I'm going to use the Hamming weight formula. That's just something I'm used to doing. So let's go over here and say, let's say num. Here we can say, well, num is not equal to 0. Let's also make sure we're keeping track of our count. So set bits equals 0. While num is not equal to 0, what is it that we want to do? So we want to do set bits plus plus. Right, this can be plus or equals 1. And then we'll say that num should equal num, I believe it's going to be num and num minus 1. Num equals num and num minus 1. So this should allow for us to get the number of 1 bits. And then we'll return set bits. Right, and then we can create our bucket from here. Const buckets equals this object literal. All right, cool. So now let's go through our sorted array. We can say for const value of sorted array. This one now, what we're doing now is we're looping through each thing inside of sorted array. Here what we can do is first we want to say const get set bits equals count set bits. Or maybe we can just say set bits equals count set bits of value. Right? That will give us that will give us one of these over here. Hey Raphael, hope you're doing well. Thanks for the opportunity to practice together again. Oh, thanks so much for joining, Rashawn. And I really appreciate I've seen you on the Discord, so super cool that you're also becoming active there. Really happy to have you, and I hope that today you can also learn something new. I think this is a pretty cool question, so having fun with it so far. For const value of sorted array, we'll get the number of bits. And now we want to say, we can say if buckets at value is equal to undefined, we can set buckets of value to be an empty integer or an empty array. Now, do we want buckets of value or is this, no, we want buckets of set bit, right? If buckets of set bits is undefined, then we'll make buckets of set bits equal an empty array. And then finally we'll say bucket of set bits dot push the value that we just got, right? And now at the end, we should just be able to concatenate everything inside of our buckets. So let me just remove all of this stuff so we don't have to worry about this. Now I can say const result. Const result is an empty array. We can say for const, what do I want to do here? I can say for const, I can go through all the different values, right? So for const num of, let's do object, for const nums of object dot values bucket or buckets, should be able to do result dot push. We'll spread the nums and then we can return result. So let's see what this gives us here. Const value of sorted array. Okay, so that was just a typo. Sorted art, I want to make sure I used, am I using this anywhere else? Okay, that's fine. Okay. 0, 1, 2, 4, 8, 3, 5, 6, 7. Okay, that looks good. Let's run the next one. All right, looks good so far. So let's submit this. Wow, phenomenal. Yeah, that's really cool. Like, I think so. I just wanted to like re-emphasize here. This explore card is really really neat. This sorting one, and I've always heard of bucket sort. Now I'm sort of starting to understand what it is. At the end of the day, at least what bucket sort says here in LeetCode is it's saying that we're gonna need to sort all the things inside of each bucket anyway. Obviously, the sorting algorithm that we pick is gonna sort of maybe become the bottleneck. But since I'm sort of already handling the sort first thing. Maybe I can actually do it, during the time that I'm pushing everything here, but I think doing it as pre-processing is fine. So let's think about the time complexity here. So we know that this is using quicksort, so this will be n log n. Now this seems like the same algorithm, same sort of thing that we do for extracting digits from a number. So because it seems like such a similar process, I'm going to say that this is going to be log n. But let's think about this. Hamming weight, number of symbols that are different, Hamming weight time complexity. Do these 2-bit counting algorithms have the same? Let's see. Actually, is there bitwise for number of set bits? Yeah, so I think oh, interesting. This is not Brian Kernighan's solution. Improve the above naive algorithm performance. Right, most set bit after counting it. n-1, n-1, count plus plus. Okay. I see. So do we get a time complexity here? It'd be nice if we did. Loop once. Oh, so is this just the amount of set bits? Brian Kernighan's algorithm. Time complexity. Ah, okay, there you go. The time complexity of the algorithm is O of log n. So let's go back here and let's do that, right? This will be log of n, which is good. That was my initial thinking. Then we have buckets. So for each value of sorted array, right? So value of sorted array, this is going to be an n operation, and it's going to be n times the set bits, which is log n. So this is also an n log n piece right here. Right, so really the bottleneck is going to be n log n for this algorithm. Now let's think about space complexity. Where is it that we're creating? So we know that quicksort uses log n of internal space. This is constant space. The amount of buckets will be equal to, let's see, is that just, how do we measure the amount of buckets that we have? Could that just be, I guess, just the amount of different numbers that have differently sized bits? Because we had only like 2 buckets here, or in this case, we only have 1 bucket for everything. But at the end of the day, this whole array, this whole object literal will hold all the digits anyway. So we can probably say it's n. So I'm going to say that this is an n, O of n for space complexity, linear space complexity, and also an n log n time complexity, maybe by the size of the bits. Yeah, that could be a thing too. And I think, you know what? Let's actually come here, because this gives us, so worst case, so the worst case time complexity of bucket sort is O of n squared if the sorting algorithm used in the bucket is insert and sort, which is the most common use case, since the expectation is that buckets will not have too many elements relative to the entire list. In the worst case, all elements are placed in one bucket, causing the running time to reduce to the worst case complexity of insert and sort. If the worst case running time of the intermediate sort uses O of n log n, then the worst case running time of bucket sort will also be n log n. So on average, when the distribution of elements across buckets is reasonably uniform, it can be shown that bucket sort runs on average of n plus k for k buckets. So it's n log n plus 2 for k buckets. Space simplicity is O n plus k, since we have to initialize an array of size k, and the total number of elements stored in this additional array is n, since all n elements have to go inside a bucket. Oh, and they're doing it with, they're just doing an array here. Interesting. Nice. This is animation of the concept. Okay, 23 goes in there, 25 goes in that one, 21 goes in that one. Okay. Interesting. Let's see what the, actually I want to run this again. Oh wait, is it gonna, okay. 55.83. $74.17. Let's see what discussions say. That's always like a good place to learn, right? One line. Oh man. Okay, this is wild. I'm not even, that doesn't help at all. Self-defined comparator. Still don't feel like it really helps. In place sort plus pop count. Java simple code, faster, bit manipulation, priority queue, one-liner, and Hamming weight. Easiest way to get the Hamming weight is to convert the number to its binary representation as a string. Okay. This is, I don't know, I don't really like any discussion. I don't like any of the discussion answers. There's nothing, I feel like I didn't really learn too much here. In place sort plus pop count. Java simple code. New int, count bit 1, return res. I'm surprised no one, bit manipulation, easy, Java, sort, JavaScript the regular way. Bit count A minus bit count B, or, okay. That's so interesting. I guess you can just run that function through. Thank you. Could you explain your code? Dapper. Yeah, I don't know. I don't feel like there's much I took from any of those. So let's just go ahead and get to the next one. Sort integers by number of 1 bits, binary tree in order traversal. Okay, awesome. Yeah, this one's cool. And you know what? Historically, I've struggled with this question, but I'm going to write it out very clearly for myself to see if that actually helps. This is going to be a good measure for me to see if I'm actually making progress here. Let's first think about the recursive way, right? And they want you to do it iteratively. That's really why this question is where it is. Because you might think to yourself, this is a very easy question, and it should exist in like the first one. Like anyone could do this, right? So here we can say, let me see, they want for us to print this out. So maybe we can say result is this if root. So if not root, return result. Here we can say in order traversal of root dot left and result, and then we do result dot push of root dot val, root dot right result, and return result. It does want me to return something, right? Okay. 132. just going through all the test cases. We're just doing this recursively. This is really just textbook traversal of a binary tree. There's nothing special happening here. So I'm not even sure if it's worth it for me to go over it, but there's pre-order, in-order, and post-order traversal. So I think that you should learn how to do all three of those. All right, now let's think about the more interesting case. Let's go ahead and construct, let's do like a 5, and then we'll have like, we can have a 3, we can have a 1 and a 4, and then we can have a 7, a 6, and a 9, something like that. And just for fun, we'll have some down here too. So let me make this a little bit nicer. Oh, but then there's also no room for, yeah. Just trying to make this nice. A good drawing goes a long way, right? So we are just constructing our own binary search tree here. So it makes it very easy for us just to see what we're working with. Okay, so here let's do a 5. We'll do a 3, we'll do a 1, we'll do a 4, we'll do a 7, we'll do a 6, we'll do a 9, and here we'll do a 10. All right, so now let's start thinking about how to do this. So let's go over, like, what I want to think about is we need to do this iteratively. And the nice thing about the recursive solution is that the stack is essentially handled by the code, right? We're going to be either in a current stack frame or by the end after we're done, whether it be the base case or we just finished on line 18 here, there'll be just like an implicit return, and then we'll just pop off the stack and go back to the next stack frame. So we have to sort of emulate that by creating our own stack, and we have to figure out how this all works. So let's go through this slowly and think about what it means to do an in-order traversal. So we start at the first one. I guess like we like ask ourselves, right? Imagine we have an empty stack. So I'm just gonna start drawing this out. We have an empty stack. Let's put it like up here or over here, right? So we're at 5. So like what I'm thinking here is like, okay, let's push 5, right? And now I ask myself, can I go to my leftmost node, or can I go to the left node? Then yeah, let's push this left node here. So now let's make this 3. And now we're at 3, and I ask myself, can I go to my left node? Yes. So let's go to 1, and let's push. Now I say, can I go to my left node anymore? So perhaps here it's a no. And what is it that we want to do? Now we want to pop, and we want to get the most recent thing, and that'll be the first thing that we print. So let's sort of think about what we did there. Imagine we have some pointer called like current. We can almost do something like while current.left, we can say push, maybe we say stack.push current, and current equals current.left. Let me make some room over here. Now, does this have to be while current.left? Because if I come here, this won't happen, and I won't be able to push 1. So maybe here I should say while current. So I start while current, yes, we push 5, current equals current.left. Here, while current, yes, stack.push current, we push 3. Current equals current.left. While current, yes, stack.push 1, we push 1 to our stack. Now I go here and I stop. So what is it that I do now? Now I can pop off. So let's say after this loop is done, right? What can we do? We can say const node equals stack.pop. Be a nice place for me to put all this. You know what? I can just make it smaller. Const node is stack.pop. So imagine we have 1. And maybe what we do now is I can say something like const result equals, or maybe we just say result.push. Result.push node.val, and now we say, now we just want to go to like the next thing, right? Like here we would do left, 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 we come here, Okay, we go over here. We just printed the left. So we want to actually do 3, right? We need to be able to print 3. So I push 1. I'm going to create like another, this second array here is my result. So came over here, this was null. I popped off. So I came over here. Okay, const node is stack.pop, that's 1. We push 1. Now if I want to go to the 3, left, 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 we pop, we go to the 1. I try to go to my right. That's where I need to go, right? I push this, but I should now say that current equals node.right, right? Because after we push this 1, in order we'll go to the next right one, right? So let's say I get to node.right, I get over here. Now we're like in null land. While current, there's nothing there, right? Current is null, so we don't do anything. We pop off 3, we push 3, we remove 3 here, and now I try to go to 4. All right, 1, 3, current equals node.right, so I'm here. While current, yes, so I push 4. Current equals current.left. Okay, now current is no longer. So I pop off this, I go to 4. Result.push. Let's see, now I try to go to 4's right. There is nothing. So current, nothing happens. I pop this off. This is 5. This comes off. I push 5. Now I try to go to 5's right, which is 7. Now I push 7. Right, I push 7 because I say current equals node.right. I'm over here. While current is 7, I can push 7, and then I go to the left, which is 6. 6 is not null, so I push 6. Current equals current.left. Cool. Now we're in null land. So we pop the 6 off. We push the 6. Try to go to 6's right. 6's right is null. This while loop doesn't happen. We pop off the node 7. We push 7. We go to 7's right, which is 9. So now we're here. We start up here on top, while current. So while 9, that is true, right? We can push our 9. Current equals current.left. Const node. So while current, it becomes null. Now we pop 9. We push 9. We go to 9's right, while current, which is 10. Push 10, go to the left. That's null. We pop 10. We push 10. So now we get here. So while current, and what is going to happen here? Because I want to, so while current, stack.push current, we're already done. All right, so I just finished pushing node.val. Current equals current. Okay, right, we come here. And then maybe here, if I say if our stack is empty, then we can just break. I think we can do that. Because what will happen here if I do pop current node.right? Yeah, I like the sound of this, so let's try this out. Let's create our stack. And let's create our result. Then we'll say let current equals root. Here we can say while stack.length is greater than 0 or current, right? While stack.length is greater than 0 or current, and here I can say while current stack.push current equals current.left. And then down here we'll say const node equals stack.pop result.push node.val and current equals node.write. Then here we just return result. So let's see what we get here. 13201, submit. 5%. Let's try this again. Surprised at that. 5%. Okay, 70. Nice. Let's try the next. Let's try it one more time. 98.77. So it got better every single time we ran it. So that's pretty awesome. I'm really happy with this. Like I said, this one, I think it's tricky to get. I think that, I'm curious when LeetCode offers follow-ups for easy questions, does it mean that those follow-ups are also considered easy? I wouldn't say this is a medium per se, but it's definitely a harder easy. Something very good for you to go through, something very good for you to learn. Highly recommend, like, you absolutely need to draw this out. If you're trying to do this in your head, then it's just not going to be good. Okay, so let's think about this. Rashad asked, what would the time complexity be here? So this is, for the binary tree in order traversal, we think about recursively, right? We're going to have to go through every single node to be able to traverse our tree, because this is not even necessarily a binary search tree. So because of that, we'll have to go through n nodes, so it'll be a linear time algorithm. As far as the space complexity goes, this right here is a height balanced tree. Like a parent never differs in height by more than 1. So this is good, because that means that the internal stack space will never exceed, it will never be more than the height. So like as you saw, as we were growing this stack and also popping throughout the algorithm, right? So it was never growing more than the height, because this is a height balanced tree. Now you can imagine instead of having all these nodes here, right? If you have like a heavily skewed tree, right? Just imagine you have something like this and then something like this, right? If this is your tree, then the stack would need to grow linearly with the amount of nodes, right? Because it's not sort of processing left and right. So here it'd still be linear time complexity, but space would also trend towards n, because this is a heavily skewed tree, which in essence, if you think about it, it's really just a linked list. A heavily skewed tree is a linked list. So that's how I think about it. And I feel like that makes sense to me. Hopefully it makes sense to you. But I'm really happy that we went through this question. I'm really happy we solved it. I think it's a very important question. So just keep that in mind. Good to draw things out. Okay, let's get to the next one. Unique number of occurrences. I think this one's like a really good question. Yeah, if I remember correctly. So given an array of integers r, return true if the number of occurrences of each value in the array is unique, or false otherwise. Each value in the array is unique or false. Oh, so 1 is 3 times 2 is 1. So, okay, so the frequencies of two values can never be the same. So we can't have, let's think about this. I'm trying to think about the best way of storing this and what data structure. Because I almost feel like we'll definitely have to keep track of frequencies, right? How do I know that they're all different? The value 1 has 3 occurrences, 2 has 2, and 3 has 1. How many numbers are we getting here? The length is 1,000. Can we create sort of like a, maybe the set? Can I create a set out of, I'm almost wondering of getting, let's see. What if I have like a frequency map? So 1 has 3, 2 has 2, 3 has 1. What if I took... Like if I had a 4 and this also had a 3, and I took the set of values, right? We'd have a set of 3, but there's 4 keys. So we'd ideally want this to be 4, and it should match the size of the keys. That's one thing I'm going to try. Think there's a better way of doing it, but we can sort of work around. We can work at it this way and see what we get. Let me just check something real quick here. Okay, sweet. So let's see. So what if we start, let's start with our frequency map. So const frequency. So let's do for const val of r, we can say frequency of val equals frequency of val plus 1 or 1. Now what if we just did const values set equals new set? I wonder if this will work. That would be interesting. Can I do object dot values of frequency? Actually, can I just spread this? Do I even need to have the angle brackets? And then just return value set dot size. I think that's mdn set. Oh, mdn set. Instance properties size. Okay. So value set size is equal to, let me see, object keys. I think object keys is something. Object.keys returns an array. But we're doing a lot of object.keys of frequency.length. Weird solution, but let's see. Value set, const value set is new set. Number 3 is not iterable. Object values of frequency. Does it want me to do this? True and true. True and false, true and false, true. Let's run this. Okay, it's kind of weird, but let's think about this a little bit. So what did I do here, right? I got the frequency of all the numbers, and if each one, like each key in my object is going to be unique, right? I'm going to have one entry for 1, one entry for 2, and one entry for 3. So like the keys alone already handle the uniqueness of the digits in here. I think, or not I think, but what I did after that was I also made a new set of the values, right, of the different frequencies, and those frequencies, the set size should match. It should be the same as the amount of keys in my frequency. Does that make sense? It's a little bit strange. I think here I'm doing right, because if we think about time complexity here, const value, this is O of n right here, having to go through every single thing in R, and then creating a new set is also going to be O of n. And then again, going through object.keys, it's another O of n. So it could be blocked by O of n. Not blocked, but that could sort of be the bottleneck. Is there a better way of doing this? I think so, because 13.82 sounds real slow. Unique number of occurrences. Number of occurrences of each value in the array is unique. 1, 1, 1, 2, 2. Can I just do it, not like in place, but no, I don't think in place is the right way. I was almost thinking like, oh, what if I just sort it? What if I just sort it, and anytime I get to, if I were to sort it, what can I do if I sort it here? So 1, 1, 1, 1, 1, 2, 2, and 3. Oh, maybe as I'm going along, when I see a new number here, Like let's say we get to, I start counting the amount of ones, and then I get to a new number, and I put in my set the frequency. And if I make it to the end and I never see a conflicting entry, then that would be true. Would that be faster though? Because I'm now sorting this. Maybe there's a way that I can do it without sorting it. But how would I ever know if I say 1, 2, 2? Like I'm not gonna know if I have any other 2s left. Let's just try that out for fun, because that could be a solution. So let's do const sorted. We'll do r dot sort a b a minus b, and let's see what we can do here. So let num count equals 0. For let I equals 0, I less than r, or sorted dot length I plus plus. Sorting will be slower, right? Definitely will be slower. Yeah. It definitely will be slower. Like I'm not even sure if it's worth going for it, right? Because we know the sorting is going to be n log n, and I don't believe anything here is taking at least that long. It might just be a lot of linear time operations. That's a good point. It's absolutely valid. So, what's something else that we can do here? The number of occurrences of each value in the array is unique or false otherwise. And they bold unique, so that's very important. That's bolded. What if I do this not in place, but without having to do all this other stuff? Can I do it as I'm counting? Can I do it in a single pass? I have a 1, and then I have a 2, that's 1. I have another 2, that's 2. I have a 1. I mean, we can also, maybe we can do, let's try this out. What if instead of using a set or anything, really I just need to make sure, let's see, 1 to 1,000. So what if we instead of using an object literal, we say const frequency is new array. We put 1,001 elements here. We're going to fill that up with 0. Now I just need to make sure that for every non-zero element, because that's the thing that I don't really like about this. How do I tell if something, like this array, dn array, the constructor, array object, yeah, constructor. Okay. Empty slots, not slots with actual undefined values. These sparse arrays, which are not the same. Okay. In some operations, empty slots behave as if they were filled with undefined. Empty slots are skipped. But in others, most notably array iteration. I mean, could we, like, what would happen if I tried that out? Let me just put this. Let me just fill it up and then go from there. Because what I'm thinking about doing is, let's go through our array. Let's start filling this up now, right? So we can do for const val of r. So if frequency of val is equal to undefined, I can say frequency of val equals 0. And then here we can just increase it. And let's also not forget those curlies. I just want to see what this prints, because with the sparse array, is it just going to print out the indices? Okay, 1 empty item, 3, 2, 997 empty items. Awesome. So I think 2, 4, and then we have a -3 here. Oh, wait a second. Each individual one, though. At every single slot, yeah, I won't be able to iterate through this now. Oh, no, wait, I can. If I just go through everything now, I need to make sure that I haven't seen it yet. So we can say const frequency set equals new set. And what if I did for const f of frequency? For const f of frequency, we can say that maybe if we've seen this already, so if frequency set dot has f return false, else frequency set dot add f return true. How would that work for, let's see, false? Ooh, false, false, false. All right, let's print this out. Console.log f. How does this actually look? Undefined, 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 1, 1, 2. Okay. Oh, and this is doing it for multiple. How does it look for that -3 one? Undefined. I only want to do the last one. This one right here. Yeah. Because I'm very interested to see how this prints. So we only get 2 and 4. We don't get for any of the other ones. 0. Could we also just fill it up with... Because the new array, the reason I'm doing this is I feel like it can save. If we go back to this way here, const frequency, const value, if we do this, if we forget about this array here, for const f, can I just go through the object values? I don't know if that's actually going to be for const val of object values frequency. If frequency set has val return false, add val frequency set. I'm not sure if this is actually too much different. True and true. Okay. True, false, true, true, false, true. Let's submit. 60.37. Yeah, I think this is going to be faster, right? Because now here in my previous example, which I removed everything, let's see if we can come back here. I think what's happening is here, yeah, I create my set and then I get my object keys. I feel like it's almost the same perhaps, but in here I'm building the entire set and then going through it and then making sure, whereas with my current one now, I have the opportunity to break early. So I don't have to build the entire set. I can be adding frequency values to my set as I go along. And because if this return false, I have the ability to terminate early, which will save me some time, which it looks like so far it's been paying off. Let me run that one more time. And then we'll look at the discussion. 26.6. Probably some. I'm expecting to see some crazy solution, as always, but that's good. Using map and set with brief explanation. Okay. Duplicates the code always to finish rolling out all occurrences before comparison. Okay. Count the occurrences of each character. Return Wow. Wow. That's literally what I said. That feels good. Yeah, like the method one, we count the occurrences of each character, and then it's almost doing the exact thing that we did here. We compare the size with a new hash set of just the values and the size of that, or we can do an early exit, which if we've seen it, we just return false. So nice. That's pretty cool. I think that's cool. Hopefully we all learned something from that. Let me just check something again. I just gotta check one real quick thing here. So how do I come to... Okay, cool. Awesome. So let's continue on. Having a good time. Having a really good time. I think we've done like 3 or 4 questions. We did this one, this one, this one. Okay, so we've only done 3. So let's get to our 4th one here. Minimum time to type word using a special typewriter. There is a special typewriter with lowercase English letters A to Z arranged in a circle with a pointer. A character can only be typed if the pointer is pointing to that character. The pointer is initially pointing to the character A. Each second, you may perform one of the following operations. Move the pointer one character counterclockwise or clockwise. Type the character the pointer is currently on. Given the string word, return the minimum number of seconds to type out the characters in word A, B, C. So type the character A in 1 second since the pointer is initially on A. Move the pointer clockwise to B. Move the pointer... Okay, I think I see... I think I already get this. Yeah, so every single spot that we're on, we can either go left or right. For every single decision we make, we just have to take the minimum distance from the left or right, or the left or the right one. For the one that we, was it the one that we just did, Rashawn, that you're talking about? The unique number of occurrences or the minimum time to type word? Or I guess the one that we're doing currently. So let's think about this. Do I need to create? I don't necessarily need to create. I don't think I need to create a... Nice. That's awesome. Yeah, I learned a lot too, Rashawn. That was pretty cool. Let's see what we can do here. Right now I'm wondering if I even need like an alphabet. Because A, B, C. So how do we do it, right? We say A, B, and C. If I go left, or let me pick a number that's easier. B, right? For me to go from B to C, I can go from 1 to 2, or from 1 and like wrap all the way the other, like wrap around the other way to be able to get to 2. I don't know why I was gonna write both things over again. How do I convey that? Would it be 1 minus the characters printed as follows? Tap the character A, move the pointer clockwise to B. Okay, so always have to be looking at the second or the next one, and then how fast I can get there. So I can do 1 plus, or we can do 2 minus 1, which is 1, modulo of 26. That gives us 1. Or we can do, let's see, like 26 minus, do we just do the distance? Would it just be 1, 2, 3, 26 minus 3? So it's just 23 steps to get there. So it'd be like B to A and then A to Z all the way until we get to C. Would that be how it is? Or is it always just... No, it would... Yeah, no, it would be 26. Would that just be 25? Maybe the 26 minus the 1, right? It would just be 25. I think that's what we can do. Something like that. 1 second. Move the pointer clockwise to B in 1 second. Okay, BZA. Move the pointer clockwise to B in 1 second. Okay, type the character B. Move the pointer counterclockwise to Z in 2 seconds. Oh, okay, so if B is... Do all these have a point value? B is 1. And Z is, let's say, 25. If I go to the right, it takes me 24 times. Right, because I take the next one minus the current one. Or I can go left, and it would be 1. That's the part that's like, how many steps do I really have to? I'm gonna have to write it out. I'm literally gonna have to draw an alphabet. So A B C D E F, A B C D E F G H I J K L M N O P Q R S T V W X Y Z. I guess at any given letter, if I want to go from this letter to the next one, it could just be 1. If I want to go from L to O, it'll be 1, 2, 3. Or, let me see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it can be 11 to 14. That's like one way. Or we do 11, right? We're gonna have to travel all the distance this way. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to get to the A. And then how many are we gonna need starting from here, right? 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Plus 23. So I guess at any given point, do we just take, and we got 23. How? Because we knew that was 14. This is 25. That's 22. So do we just add 1? Is that how we can come up with that formula? Forward or add the distance between where I currently am, which is the 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 25 minus 11, that gives me 14, right? That's 25 minus 11, 14. That's the actual thing. 25 minus 11. So it'll be 11, it'll be current position plus 25 minus current. Or it can just be current position. Or it can be the next one. It could be like where we want to go. So something of like where we want to go minus current position. So it'll be the min of these, right? Because 14, so O is 14 minus 11, that's 3. But if we wrap around the other way, that'll be 11 plus 25 minus the current position. 25 minus 14, that'll give us that big number. I think this could work. So can I? Okay, I can copy all this. So let's do this. Let's think about this. Where we want to go. All right. Let min equals 0. For let I equals to 0, I less than word dot length. I'm going to do -1 because we always need to get the next one, right? I plus plus. So immediately move the pointer clockwise to B in 1 second. So do we just start? I guess we always start at the first one. Move the pointer clockwise to B in 1 second. Type the character B in 1 second. Oh, and we start at A. Right? I think that's what it says. It always starts at A. So let's say let previous start or previous equals 0, let next equals 0, right? I'm saying previous is 0 because 0 represents A in this case. So here we can do const where I want where I want to go. Here we can do, what do we want to do? I need to get the digit of the letter I'm currently on. So let me do that. Const character code equals word of I dot car code at 0 minus 97. Right? That'll give me the B. And previous is 0. So that's fine. Where we want to go minus current position. So I want to go to B. Right, so here, yeah, I think, yeah, it can just be B minus, so let's do character code minus previous. That's where I want to go. And now const, or maybe not where I want to go. Maybe this one should just be right. And const left should be the current position, which is character code plus 25 minus character code. And then here we can say min plus or equals math.min of left or right. I can make previous. Oh, and then we'll always add 1, right? Because we're going to also spend time to type it. So then we can do previous is equal to the character code. So will that work? Return min. We should, well, let's just run it and see what happens. I mean, that's how we learn. 3 and 5. Okay, let's figure out what happened here. We have A, B, C. A, B, C. So I do 97. Actually, that's a very good question. I'll explain that to you in a second. So my previous, I'm starting at A. Right, so A, B, C, type the character A in 1 second since the pointer is initially on A. Previous is 0 and next is 0. Okay, so my character code is 0 minus 97. So it's 0 minus 97 because I sort of want to normalize each one of these, right? So A is sort of the, like if you think about an array of 26 where each index represents a letter in the alphabet, I want my A to become 0. I want my B to become a 1. So for me to sort of set these in their correct positionings, I have to subtract a normalized value. I have to normalize them. The number 97 is the decimal value of lowercase a in ASCII. So if I take the car code at 0 here, it will give me A, for example, in this first one. That's 97. If I subtract 97, I'll get 0. So now A is normalized to 0. If I do B, so word of I, imagine this is B. B.car code at 0 is 98. If I do 98 minus 97, I get 1. So that's sort of how we can go about doing that. So we have previous, okay, so const right is character code 0 minus 0, which is 0. And then left is 0 plus 25 minus 0. So it'll be 0 plus 1, that's just 1. And then previous is character code, which is 0. Okay, that's cool. Previous is character code, which is 0, but min is 1. Okay, now we're going to move the pointer clockwise to B in 1 second. But am I doing this? Am I doing this like prematurely? Because I haven't actually accounted for moving it. If I go directly to the B, now I'm just considering B and C, but I haven't actually done A and B. So maybe what I need to do, yeah, I definitely got to take the first one, A, B, C. Yeah. Wait a second. Character code. Yeah, here we should do I+1. Let's see what happens here. Is ABC? It might not like that. Yeah. Let's see what this does. Ooh, close. Close. We're making progress here. Let's see. For character code, word I+1. So that's B minus 97. Const right is 1 minus 0, which is 1. Const left. But see, again, I'm not considering that initial one. So maybe we should, if we have ABC, and we start at A. Let me move all this stuff. Maybe we should do A, like calculate distance from A to A, sum that, and then go to, yeah, calculate distance from this one to this one. Okay. And now make the previous one this one, and now do this one to this one, make the previous this one, and then do this one to this one. I know we're very close here. It's a matter of that first one that I need to get. That's the one that's messing me up. And I wonder, can I just do a one-time? Maybe I should initialize min not to be 0. It should be, maybe it should just be this, and this is not awesome, but let's do this. Let's create a function. And let's say calculate min distance of previous and next. All right, so assuming that we have character codes for each one of these, const right. So I can go previous, or I can go next minus previous, or I can do previous plus 25 minus next. And then we just return math.min of left and right. And I won't do the 1. I won't add the 1 here. And actually I can just return math.min of left and right. Here, maybe what I can do is say calculate the min distance of A and whatever is at word of 0, right? That's going to be the initial one. And now let previous and next. Do I really even need this anymore? Maybe I can get rid of this. I can get rid of this. I'm going to get rid of this one. So now we already have a starting min. Now we just need to get the distances of A to B and so on and so forth. So here we can do, I want to get character codes, right? So let's say previous car code is word of I dot car code at 0. Const next car code is word of I plus 1 dot car code at 0. And yeah, we need to add in the 97. This is already handled by a method. So can we just do min plus or equals calculate min distance? And you know what? Let's also just, let's keep this easier. Previous and next plus 1. And then we should just go to the next one. Return min. Let's see what this does. Not a number. Beautiful. Oh, wait a second. Let's just make this 0. Right, because the car code of this is 0, and then we can just do word.0 car code at 0. Let's run this. Negative 68. That is wild. That's wild. Here I'm already dealing with, let me see, next, right? Because to get to the right, if I do next minus previous, so this is 0, word 0 dot car code at 0 minus 97. This is like where I hope most of the value comes for the stream. Just like understanding how I'm making these mistakes. Wow, and we're literally left with the same thing again at the end. I wonder if it's because is there like a 1 that I need to add? Because this one will move it to C, it'll do this thing, and then I'll add 1 for that next one. What if we just, adding 1 here seems a little bit strange, and like it's gonna pass for this first test case. It doesn't mean that it's right though. Let's see. -5, -20, and -19. Bad times. Previous plus 25 minus next. Let me just make sure I'm getting all my character codes here right. Car code at 0, word of I plus 1, car code at 0. Calculate the minimum distance of previous and next. Plus 1. Math.min of left and right. Previous plus 25 minus next. Right equals next minus previous. That's some weird numbers I'm getting. Yeah, my whole thing is like set your initial minimum to just going from like A to A, or A to whatever the first letter is here. And then from there you just calculate this distance and this distance. Now when I go from B to C, like I'll do calculate distance plus doing the 1 to type the A. Then I get here, I go from A to B, do the 1, B to C, do the B. Then I get to the C, so that's probably why I have to add the 1 at the end, so I can actually take time to type the last character. Now, why is it that we're getting previous plus 25, previous and next? Where are these negative numbers coming from? B, Z, and A. Like to go from A to B is going to be 1. From B to Z, what would be better? Like 25 minus 1, 24, or 1 plus 25. Oh, wait a second. No, this should be previous, right? I want to still calculate the same previous plus 25 minus previous. Oh, Jesus. We're so close. We're getting there. B to Z to A. If I go from A to B, I'm going to choose 1. That's going to take 2 seconds to type A and then go from A to B. Now I go to B. If I go from B to Z, that'll be 1 to 25 on the right side, right? That will be next minus previous, 25 minus 1, that'll be 24 if I go to the right. If I go to the left, I can do 1 plus 25. Yeah, no, it shouldn't. Maybe this shouldn't be previous. From B to get to Z, if I go the other way, this is probably some modulus operation too that I could be doing. B to Z is 25, or if I just go backwards, if I just subtract, well, it's like the same as wrapping backwards, right? If I do 3 plus 25, or just say 28 modulo 6, modulo 26, that's 2, 0, 1, 2, we should end at 3 if I add 3 to the z. Now if I go the other way around, 28, if we do 1 minus, how can I end up at that number? I'm going to have to at least subtract the distance between... Wait, to get to the right, it's going to be previous, where I currently am. If I'm at 1, that's going to be 1 to get to the 0. Now is it 2 to get to z? So should it be another one here? 25. What's the distance of... No, maybe this one should be next too, because then this would be 2 plus 25 minus next, which is 0, right? Because we're saying that z, like z dot car code at 0 minus 97 is 25. So 25 minus 25 is 0. Left is 25 versus, or left is 2. Math.min of left and right, that's 2, so we should add 2. We get a 3. I know we're close. I feel like this is an edge case. So I'm gonna table this one for probably like tomorrow's stream. Just, I know it's a little over the hour. Let's see if we can do one more. Oh man, awesome. Beautiful question. Reversing a linked list. This is, I mean, look at this. This is like top tier question. Previous minus 25 plus 1. Let's try that out. Previous minus 25 plus 1. I'm excited, man. Previous minus 25 plus 1. Yeah, it's probably such a simple math thing, and I'm just getting it wrong. Previous minus 25 plus 1. So it seems like we're getting more negative numbers here. Previous minus 25 plus 1. And these also correspond to like a lot of the letters too, because 68. Hey man, but that's good. That's why I like we're doing things here live. That's the point. LeetCode live. You know, this is where you get a lot of the value that I hope a lot of you guys have been getting. I think what I'm gonna do actually, because I wanna do this one iteratively and recursively, and I want to have a chance to explain it. So I probably will stop the stream here today, and then tomorrow we can start strong with reverse linked list, which is a really nice, fun question to get into. We did 125, so I think that means we did 3 questions today. So a little bit slower today, but that's sort of like, again, the point of these live streams. We'll have different mileage. Sometimes we'll do 3. Like yesterday, we did 6. I thought yesterday's stream was particularly good. So for anyone that is watching, just a quick recap. So I have these posted on my LeetCode live channel, and I do these daily. So if you're interested in seeing these daily streams, learning a thing or two, hearing me make mistakes, you know, watching me struggle and also make mistakes, and at the end hopefully coming up with some optimized algorithm that we can benefit from, then you're in the right place. If you think this is going to benefit you, you know, I'm looking forward to having more of you around. We've been growing, I would say, pretty fast. I mean, we're sitting right now at 145 subscribers. I want to do like a subscriber special at around 250. I have to think about what it is I'm going to do, but I know at some point, definitely I want to be able to gift LeetCode Premium subscriptions to people. I'm thinking about like having contests or really like anything that will just like help drive more of an audience and just like have fun with it, you know? But in the meantime, I'll see if I can think of other things to celebrate those milestones. So tell your friends, get everyone you know on board. If you like what you see, subscribe to the channel. If you want to be notified of when I go live, make sure you ring that notification bell. and we'll go from there. So hope you guys have a great rest of your Wednesday. Rashawn, I will also see you tomorrow, and you all have a great rest of your Wednesday and happy coding. Later.